Alright, so we talked about segments in a previous video. Right now we're going to talk about measuring those segments, and essentially it's just finding the length of those. Now the general notation, remember, just to review, when we were talking about a segment, say we had a segment from point A to point B. Remember, we named that with a just the two letters, the two endpoints, because it has a start and a stop, and then we put a little bar over it. When we're talking about the measurement of a segment, this is the measure of segment AB here. So that's what if ever you see there's no bar over that, it's probably not a typo. Now this doesn't mean line AB, this doesn't mean segment AB, this means the distance between A and B. So that's the notation for these. And there's a little example. Say we want to find how long this fish here is. All right, and we want to measure our fish, but the front of the ruler is all worn out. Could you still measure it? Well, yeah, sure you could. Well, let's see. Like right here, this thing ends at 16. We don't know where it begins, but what we can do is we can shift this fish over to the end. So let's. What we'll do is we'll just kind of like move the fish over. If you kind of redrew this fish, you know, like here. Like it might come like this. You could slide it over at the end of the ruler, and you just do, what would you do? Well, let's see. Here it ends at 30. If you're like not confident that that's 30, but I promise you it is. You can start it at 29, and let's say it falls between 29 and 20. Well, that means it's going to be here, and assuming the units are inches, that's going to be 9 inches. Let's say if we slid the fish over, and if it was between like 18 and 26. How long would it be then there? Well, you could actually just count the spaces in between, but what's a quicker way, especially if you're dealing with bigger numbers? You just do 26 minus 18, that's going to be 8, so this is, this would be the 8 inches in this case. So we can really just find distance or measurement by finding a difference. And that's very similar to what we're going to be doing. First, we're talking about the ruler postulate. All this says is that it says we can assign numbers to points on a ruler. So like here we can assign, say we could assign this as the number 1. Then we could say we'd make this evenly spaced. If this here was assuming these are inch marks and they're not really that thick there. This would be 1, and then see how there's like 3 spaces here, and then this would be 2 here, and then this, we have 3. So like B would be like 2 2/3. So we can assign numbers to this ruler, and that's what we're doing. And when we say the coordinate of A, this is just the number assigned to a point, essentially. Now you may have remembered in like algebra the coordinate plane. Maybe you talked about that. Well, we had this was 1, 2, 3, 4 on the x, line. This is like this. Think of this as the x ruler. This is your y-axis. This is like your y ruler, and these were your numbers here. And we even went into negative numbers, which we can deal with those too. But this is the coordinate plane there because it's a plane. Remember we talked about plane last section, and it has coordinates, which just means it's a numbered plane is all it is. Now when we're finding the measurement of something, we're finding the distance here, just like we did with the little fish and the ruler, and we took, let's say it was between 16 inches and 28 inches, we just subtract those numbers. So if you want to find the distance, all you do is you subtract the numbers. Now A is that capital A represents a point, B represents a point here. So you do their difference, you do B minus A. Now technically, couldn't you also do, use this example where, let's let this be A, let's let A be 16. Let's say this is at 16 on the ruler. This is at 28 on the ruler, whether it's inches or not. Alright, you could do 28 minus 16, that gives you 8. What if you did it backwards? What if you did A minus B? Well, this would be, see here we'd have 28 minus 16, that's 8. If we did 16 minus 28, you would get negative 8. But if we want for distance, we can just actually, if we took the absolute value of that, which distance can't really be negative when you think about it, Like, this fish couldn't be negative 8 inches long. It's 8 inches long whether you start from one direction or from the other, because remember segments, you can reverse them. So we're going to say the distance is actually the absolute value of the difference of the coordinates. So it doesn't matter, the order shouldn't matter, but typically you might decide to do bigger number minus smaller number just because that's the way we think. All right, if we want to find the distance of ST, now we can actually just, let's say you don't trust your arithmetic. You can just count. Now be careful, I count 1, 2, 3, 4, 5, 6. That's 6 little hops here, but each hop is 2 spaces, so it's 2, 4, 6, 8, 10, 12. That's fine here, so distance should be 12. Now, there's no units here, it's not inches. It's just going to be 12. I'm not going to put units because there aren't any units labeled, but if it was on a ruler or was a more real-world application, actual problem, instead of just this simple exercise, I'd put units. But I'm also going to I'd rather just do the subtraction just to practice it. You do the coordinate endpoint minus the coordinate endpoint. Be careful here. You might write that 8 minus 4. Oh wait, it's 8 minus negative 4. Remember, when we subtract the negative, what happens is you can kind of change the sign on both. So it's really 8 plus positive 4. Again, it's going to be 12. Okay. What are UV? Now read this just like we read. If it had a line over it, we'd read that as line UV. If it had a ray symbol over that, we'd read it as ray UV. If it had a segment, we'd read it as segment UV. This, in your head, you should read this as the measure of segment UV, or the distance between point U and point B. And similarly, this would be the measurement of segment SV, or the distance between S and V, those points. So UV, well, let's label those points U and V. So that's going to be 14 minus 10, which is going to be 4. It's 4 units, whatever those are. S and V, let's see. So V is still 14 right here. S is negative 4. Be careful. Again, don't do 14 minus 4. It's 14 minus negative 4, because if you count it, this to 0 is 14. But then we go 4 past 0. So that's why you're adding those. So you may wonder, when are you ever going to subtract the negative? That doesn't make sense. Well, this is when you'd subtract the negative. So this would be 18 units. So, and here's how I write that. I'm going to write ST equals 12. That's the correct way to write it. UV is equal to 4, right? And then SV is equal to 18 there. All right. The segment addition postulate, really quickly, what this is if you have 3 points and they're all on the same line, let's say this distance is x, this distance is y, well, the distance of x plus y is going to be equal to the, your total. Now, that's not true if they weren't linear. Let me show you just a quick counterexample. What if you had this? Let's say it was like, let's call this A prime, B prime, and C prime. So, sort of similar points. Would the distance of x plus y give you the distance from, between A and C? And it actually wouldn't if they're not collinear. Isn't that really the distance between A and C? So, you can actually shortcut it. So only if they're all collinear and this point is in between here, and we say, if A, B, and C are collinear, then and collinear with B between, I'm going to abbreviate that, A and C, then AB, the distance from A to B, plus BC, the distance from B to C, is equal to AC, that total distance. And if we put that into practice, all right, this distance plus this distance would be EG. They tell us EG is 59. So here's what I have. I know that EF plus FG is 59. So I'm going to write 8x minus 14 plus, that's EF, 4x plus 1 equals 59. And so I'm going to combine like terms. Just a little bit of algebra, combine these expressions. 12x minus, all right, negative 14, positive 1 is negative 13 equals 59. Add 13 on both sides. And so we're going to get 12x is equal to 62. Divide by 12, divide by 12. And I feel like I made a mistake. Oh, that should be 72. That's why. And so you get, this is going to be equal to 6, so x equal to 6. All right, that's a few problems. And this is one that's very similar. You can work that one out. We'll talk about the definition of congruent. Congruent just means equal. So congruent means the segments are the same length. They have the same measure. these are some more practice problems. You can work on these. What I'll do is I'll make a part 2 of the video, and we will do the rest of these slides. So that's the end of this part of the lecture.
The views and opinions expressed in this video are solely those of Mr. Vogel and do not necessarily reflect those of the schools of Harvard, Details, Board of Directors, Administration, and the University of Schools, or anyone else. Visit our website at shskoto.org.